Hello everyone, welcome to AI Anytime channel. In this video, we are going to build a tool, a Python library that will help us evaluate RAG systems. RAG is an acronym for Retrieval Augmented Generation. You would have been building hundreds of chatbots using LangChain, Llama Index, Haystack, and so on and so forth. You will be building conversational interfaces. You would have been doing it, all of these, and also probably using some evaluation tools given by LangChain or any other third-party tools as well. But have you imagined that how these guys have built this tool? You can also do that. So you should know about the algorithms, the evaluation metrics behind these evaluation tools. Evaluations are really important when you are building a RAG system use because LLM has tendency for hallucinations. Large language models hallucinate a lot, and there are obvious reasons for it because the data might be biased, the data might not be factually correct, so on and so forth. Now, how can you build your own evaluation tool? And that's what I'm going to show you in this video. This video will have everything that you need to understand about evaluation of RAG and how different tools, even LangChain gives you multiple evaluation packages or modules that you can try it out. There are other tools in the market. You have GPT eval, you have evals.py, you have tools like Giscard, TrueLens, and even weights and biases have some plugins. So there are multiple tools, and you can also monitor it, you can also evaluate it, and this is what I'm going to show. I'm also going to show how you can build a Python library out of this tool, a Streamlit app, a Python library on different evaluation metrics like BLEU, ROUGE, and you know tons of other. We're gonna look at BERT Score, we're gonna look at BLU, we're gonna look at rules, we're gonna look at biasness, hallucinations, racism, blah blah blah. Okay, and you can expand this library. I have made it completely open source. It's available on GitHub. Now, without any further delay, let's jump into it. Right? If you look at here on my screen currently, I have something called RAG System Evaluation Dashboard. Now, this is a Streamlit app that I have created. Just to show you some quick examples. If you look at here, it takes three inputs, and I'll also tell you that how you can basically do it all in real time. So you have built a RAG, and if you want to, basically send all this data to this tool, for example. Now imagine if you have a fast API driven application or an API that basically gives works as a RAG system for you, and if you want to send data from there to evaluation tool, how you can do that? I will also tell you. Basically, you can use some webhooks to send the data whenever there is a new results get generated by LLM and there's a new context. Webhooks will get all the data from there, and you can basically use these algorithms to show that. That's how TrueLens does it, by the way. Now, if you look at here, I have passed question. What are the causes of climate change? Reference context, which is your top K document. This is coming from the retriever. For example, if you have a vector database or a vector store like Fast, Chroma, Qdrant, Milvus, blah, 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 Pinecone, or any other third party as well, you will have some top K documents, which is coming from the retriever. Now, this is your retriever. This is your basically context, references, whatever you call it. And then you have an LLM generated output. So LLM looks at this question, LLM looks at this context, and it has some prompts template, of course, all binded together, and then it generates an output. And then this is the evaluation results that you see. So if you look at the evaluation results, it first gives you BLU score, which is bilingual evaluation understudy. I'm going to tell you about these things in detail. It tells you that 21.82 BLU measures the overlap between the generated output and reference text based on n grams. Now, n grams can be number of words or tokens, whatever you call it. So, we're going to talk about that in a bit. Higher score indicate better match, right? Now, I'm also explaining these metrics because end user might not be aware about these algorithms or metrics. Then there is rules one score. ROUGE measures the overlap of unigrams, okay, between the generated output and reference text. Higher score indicates better match, okay. And if you look at the BLU score is not good, okay, and they are probably used for other use cases like translation, summarizations. I'm talking about BLU and ROUGE. Now look at BERT precision, BERT recall, BERT F1 score. And guys, this is not There's nothing new, guys. I was talking to some of the Google engineers, and they all talk about the same thing. It's all same. It's very easy. Same machine learning, same algorithm, same statistical algorithm, probability. Everything is same. People have made it fancy, to be honest. Okay, but you will still have to use the same confusion matrices, to evaluate the retrieved chunks or whatever, right? If you look at here, the precision, the recall, the F1 score. Now, BERT score evaluates the semantic similarity between the generated output and a reference text using BERT embedding. So that's basically gives you the evaluates evaluation of the semantic similarity between the output and reference text using BERT embedding. So we are using a BERT embedding model, and then we have perplexity, not the perplexity company, but perplexity and burstiness are the two metrics. It became famous after the rise of generative AI models. But perplexity helps you to find out how coherent a text is, when generated by large language model. So if you look at here, it says perplexity measures how well a language model predicts the text. So it basically for the next word prediction. Lower value indicates better fluency and coherence. So the text should be coherent, right? And so you can see it's lower value. So this looks good. Okay, and then you have diversity. Now diversity measures the uniqueness of bigrams, two words in the generated output. Higher value indicates more diverse and varied output. So you can look at it, it's 98%, right? So diversity is 98%, perplexity is around 7.34. And then I also have racial bias. I'll tell you how I've calculated it. It says racial bias score indicates the presence of biased language in the generated output. Higher score indicates more biases. Now, all of these are individual metrics, guys. It depends on what kind of system you are building. So there are three scope to this. If you look at the current YC uh, cohort that they are selecting a lot of evals the startups which are working in the field of evaluation, not rocket science, guys. It's a very conceptual and fascinating field. You need a lot of expertise to work with these kind of products if you want to build this. So the scope of this video is to inspire you so you can also build a evaluation tool of your own. It's not rocket science, trust me, it's easy if you just understand the concepts. So YC is looking at a lot of evals because now YC knows that enough of AI wrappers, because every time OpenAI comes up with an update, 90% of the YC startups become obsolete, and that's why they are looking at something else, which is good. Now that's the one scope that you can look at this. You can build a product of your own. You can build a SaaS product that can connect with different systems of RAGs, chatbots, blah blah blah, and you can just give them the evaluation score. That's the one perspective. The other perspective towards this is that you might want to learn different evaluation algorithms. That's one more scope here. And the last one is to build a Python library so you can use it in your own chatbots at your workplace, right? So most of the time you need custom algorithms or custom, of course, you need self-hosted custom algorithms and architectures to work with. If you are on-prem, you are working in a regulatory industry. So these are the three scope. I leave up to you what you want to do with this. Now, these are separate. You can also come up with different logics. You can put some threshold values. For example, if diversity is less than 50%, then you say that there is something wrong with the LLM output, and so on and so forth. So I leave up to you. Now this is a tool that I have built. I'll show you how I have built it. But there is one more thing here I want to show you, which is a Python library that I have pushed. You can see this is what I have released. I've released about an hour ago, and now this is available on GitHub. You can see this is a project. I'll give the link in description so you can fork this, you can expand, you can use whatever you want to do, you can do that with this. Now this is a very well documented. Probably you can also make changes. Just do a PR here, pull request, and I'll accept your PR as well. Now, this is a library that we have built for the same evaluator, and I've shown you that how you can use this library. You just have to install pip install rag evaluator, and then just from rag evaluator import rag evaluator, and then initialize the evaluator, and then give your input data. Now here something that you can get it from LangChain's responses if you are using LangChain framework, like whatever chain you are using, like retrieval chain, conversational chain, whatever. And then you have matrices, metrics, evaluator.evaluate all, question response reference, and then you print the metrics. It gives you a JSON response with everything. Now this is what I also have wanted to show you. I thought this will be helpful. And now I'll go to code in a bit, but let me explain that a few things here. So I'm going to explain on a very high level all of these things, and then we'll go into a code. I'll show you the VS Code. The code is here, guys. Do not worry. Okay, so for example, if you don't want to understand the algorithms, just jump into the code part. Okay, and I'll go into the algorithms first. I'll just quickly cover it. That what do I mean by that? First, I'm going to talk about is rag eval. You can see it here on screen. Let me just show it. Now, on the rag eval, the first thing that we're going to talk about today is very quickly is called BLEU. Let me just write the full form for this. It's called bilingual. So it's called bilingual evaluation understudy, a very famous metrics, guys. It's a metric for evaluating the overlap between the generated text, which is the LLM generated text, and the reference text based on number of grams. Now, n grams is something that you can set it. So when I write that overlap between generated text and reference text, and then it is based on the n grams. So focus on this word called n grams because this is where the magic happens here. So I'm going to write n grams, right? Now I'll give you a, so basically it measures precision by calculating how many n grams in the candidate match the n grams in the reference. So basically words by words, right? Now, uh, no, of course not the best metrics, but you can combine. See, the entire logic here is that you probably one metric will not be enough to evaluate a RAG system. So you need a combination of different metrics to come up with a narrative that the model is hallucinating. You can also use some fact checking algorithms. I can talk about that in the last, but there are multiple combinations, permutation and combination that one has to do. Now this is fine. Let me just show a mathematical expression here. So the BLU is, so I'm just going to write. So BLEU is defined as BP, and I'm going to talk about this. I'll explain exponential, and then it goes summation of n to n equals 1, and then Wn, and then log, and just let me do that. Now I'll tell you what all of these things mean here. Okay, I'll narrate that. Okay, now this is something called brevity planning. Uh, Not planning. I think it's brevity penalties. Sorry for that. Brevity penalty. I'll explain that. Plan penalty. Sorry, it's a penalty, and then you are having. So basically, it's ensure that the shorter generated text are penalized. So for example, if there is shorter generated text that probably which is not matching in both references and the generated text, then that will be penalized, right? Now that's brevity penalty, and the next is PN is this one is the precision of n grams. So let me just write it over here. Precision of n grams, and then Wn are nothing but the weights that you assigned, okay, to each n gram. So they are commonly equal weights. Okay, so I'll just write here weights assigned to each n gram. And this is how you define it. And in the context when you are building a RAG system, guys, in the context of RAG, BLU can be used to evaluate how closely the generated responses match the retrieved context. So for example, if LLM generates a response to a question, if you look at here the question that we asked, it was about climate change. We ask what is the causes of climate change. BLU can measure how similar this response is to the reference text describing climate change. That's what it does. Now I'll probably you can also go through some examples. Now, one candidate can be, so let me just write it like this. So let me just do here. I'll go back on my screen grab and come here, and then I'm going to write candidate. So when I'm writing candidate, let me just do that climate change is caused by, for example, this is your LLM generated response. Climate change, excuse me. So I'm going to write climate change is caused by human activities. Now this is what I'm going to write here. This is your climate candidate. Now here is your chunk. So this can be one of your top K documents. So for example, if this is your top 0, which is the first retrieved context, then it might have something like this. So for example, if you write human activities such as burning fuels cause climate change. Now, if you look at the generated output from this, then it makes sense to you. Then you can say that okay, now LLM has able to reason it out or able to figure it out that okay, from this reference I have to generate this kind of responses, and that's where BLU comes very handy. And this is how you can define BLU. The next is, let me just go to next, which is ROUGE. Somebody told me that ROUGE is a flower. Okay, so it's a flower. Okay, and it's a acronym for recall oriented understudy for gisting evaluation. So let me just write this. It's overlap of, again, not writing the full form, can get it on internet. It's basically measures the overlap of n-grams between the generated text and the reference text, focusing mainly on recall. So I'm just going to write here, focusing on recall. So it focuses on recall, and it measures word overlap. It's the same like, of course, BLU, and it has, so there are different versions of ROUGE. So there is something called ROUGE 2 as well. Probably you can find it out if you're reading it on internet. When you do ROUGE 2, it basically measures the bigrams now. So it basically measures bigram overlap. And ROUGE, if you write ROUGE L, so this is how the terminology is defined, if I'm not wrong. So there's ROUGE L. Now ROUGE L, this is something that you should look at it out, because this will help you in the context of large language models, because the LLM responses are lengthy. So it measures the longest common subsequence. This is something that you can have a look. You can also have a look at ROUGE 3, ROUGE 4, whatever. The depend how many, what kind of use cases you are solving is something that also depends on, guys. Okay. Now ROUGE mathematical formula is a bit complex, so I'm not going into too much of mathematics. Please read on internet. It has reference summary, and then it has, n-grams, blah blah blah. I'm not going into that definition right now. Now, very similar. Let's talk about the BERT score quickly. It also has, for all of these, we have library. I'll show you what library you can use when we are going into the code. Now, BERT score evaluates the semantic similarity. So this is very helpful if you're building a knowledge base kind of if you're solving a knowledge base kind of a use case. Now, semantic similarity. So let me just write it out. This is for semantic similarity between the generated text and the reference text, right? Using BERT embeddings, it uses BERT embeddings in the backend. So let me just write it out over here. And it compares mainly, it happens mainly on the token level, guys. So the token embeddings that you have from BERT, and measures precision, recall, and F1 score. So it's basically gets all three of it. If you are working in the field of machine learning or data science, you'll probably aware of this. So it basically looks at precision, recall, and F1 score. F1 score, harmonic mean of precision and recall. People used to ask this question in interview, what is F1 score? We always used to say, hey, look, harmonic mean of precision and recall, blah, blah, blah. So this is like nostalgia. But anyway, uh, BERT score, I'll probably you can, is pretty much self-explanatory. I'm not going too deeper into it, guys. And then we are going to go into talk about perplexity. So let me write perplexity. Perplexity is one of the most important metrics, probably, when you talk about large language model, because it helps you find out how coherent or random. This also can be used to detect patterns in machine generated outputs. You can find out if a text is generated by AI or not. You can also do that, using perplexity kind of algorithms. Now, I already talked about it. I'm not going into mathematical formula, but probably in so basically, if you have a RAG, perplexity can be used to measure the fluency and coherent. As I said, generated response, make sure that it has a lower score, so lower perplexity. So perplexity should be lower. So let me just write lower means coherent, more coherent sentences or text, whatever you call it. Okay, basically I call it text. So coherent text. This is how you define perplexity. So keep this evaluation things in mind. Then we have diversity. So let's talk about diversity quickly. And in diversity, measures the again uniqueness of n grams in the generated text. Now just imagine, right? It's very diverse. We say now somebody is very diverse, come from a diverse field. Now if I have experience, in different domains, like for example manufacturing, procurement, real estate, blah blah blah. So I can say that I'm a having a very diverse experiences, right? Now that's what diversity does as well. It looks at your different n grams, find out the uniqueness of n-grams in the generated text. So if you have basically it's very common sense, guys. If you have more repetitive text, probably the algorithm will say it's not diverse, and that's why I say that might not be the best way to look at it. But higher diversity indicates a wider range of vocabulary, higher range of vocab. So when you are working with large language models probably will have large vocab, right? If the model is better, and that's how you can measure it. So let me just write it over here. So you should look at that. So if this is higher, means large vocab. This is how you imagine it, and structures. So I'm also going to write it structures. And this might be important. And diversity is very simple to define, guys. And if D is diversity, then it should be unique n-grams. So it should be unique n-grams and then divided by total n-grams. And total n-grams. That's how we define diversity, right? And uh, you can find need more words like fossil fuels, deforestation, industrial processes. So there are all different words like fossil fuels, and then you have deforestation, blah blah blah. So if you are just repeating fossil fuels, it might not be diverse. So answer might not be diverse. So keep this. They're all algorithms, right? Now the next is racial bias. For racial bias, I used a standalone model there, out of a box model on Hugging Face. I'll show that when I'm writing the code. Let me just write racial bias. You can also look at WEAT for demographic diversity analysis. I forgot the full form of wheat. Uh, Something I forgot. I have a video on that. But if you want to find out if an LLM is giving you responses, if you are building a use case where you have to hire uh, candidates from different geographies, that's one of the use cases which just came in my mind, right? You have a system that recommends profiles from different geographies. Then you can use WEAT there, diversity demographic analysis, to find out if system is have enough distributions, from different geographies. Because people should not claim that okay, you are only recommending profiles from, one particular geography. That might not sounds good, right? As an organization, your reputation will be in danger. So you can use these kind of algorithms over there. Now in racial biases, uh, I'm using you so basically find out offensive languages. It's pretty easy. So offensive languages, look at it can based on natural language intent. Look at the context and look at different words, vocabulary, black, Asian, Americans, blah blah blah. If you have these kind of words as well, it can be a signal of, hate speech, biasness, and so on and so forth, right? So uh, you can look at their, like for example, if you have text like, if machine generated text like, Asians are responsible for environmental damage, then it's a biased response toward Asians. So these kind of intent, you can look at it, and I'll show you a library. But this is what, these are the algorithms that you should look at it if you want to build a evaluation system: BLEU, rules, and BERT score, perplexity, burstiness, diversity, racial biases. There are other as well. Let me write it down. So I'm going to write it. You can check it on internet. So wheat. Then you have fact checking algorithm. For this is good for real time RAG system to find out hallucinations. So fact checking algos. And then you have what else? So wheat is there. Then we have fact checking algos. Then we have burstiness again. So burstiness also helps you with coherence and randomness. Now you can combine all of this and you can build a very good system, guys. You can build a tool, build a product, build a SaaS, sell it off, integrate, and go into anywhere you guys want to go, right, with that product. And that's the theory. Now let me go back to the code now. Okay. Now let me show you something, guys, here. Look at the tweet by Greg Brockman. Uh, Probably if you aware of OpenAI, and I hope you are aware of OpenAI. Greg works at OpenAI, is one of the founding member. Okay, and he has a tweet called "Evals are surprisingly often all you need." Evaluations are all we need for adoptions. If you want to adopt If you want to see adoption at the higher rate in enterprises, you need to focus more on evaluations rather than building a chatbot. Anybody can do that, guys. So that's where it's important. Now, let me go back to code and show you. So here is my code. Okay, so I have two files, the Python files, and then I have a requirements.txt. Now, if you look at the requirements.txt, I am using Streamlit, I am using BLEU, I am using ROUGE score, I am using BERT score, I am using transformers, torch, NLTK, which is natural language toolkit. These are the requirements. Create a virtual environment. You can see I have a virtual environment called .venv. I have installed all the requirements, and now let's go back to evaluation module.py. This is our bedrock for this entire app. Now I've imported everything that I need. I'm using a GPT-2 model. Feel free to replace that model with any new models like Llama 3 or 5.2, 5.3, blah blah blah. Just because of infrastructure, I'm using a smaller models to show the capabilities. Now from secure blue, I am getting corpus underscore blue. From ROUGE score, I am getting ROUGE scorer. From BERT score, I am getting a score. From transformer GPT, just to load the models and process it. And then from natural language, I'm using ngrams. I have a class which is RAG evaluator. In the RAG evaluator, let me do an alt J so you can see it. Now I'm getting the GPT-2 model. You can see it over here. And then I have a bias pipeline for race. Now this is a model I am using and I'm doing a zero sort classification through that pipeline. Now this is a model that by head speech CNERG, this is an English model that's called DHead but mono English. Now I'm using this model to find it out, when the machine generated output, if it has bias, if it is if it's bias or not. That's what I'm doing using this. Now I'm loading the GPT-2 model using this function you can see, and I'll tell you where we're going to use this model. Then I have a function called evaluate. So I've created different functions. So you can also use this differently in your applications. Now evaluate BLEU rules. You can see it over here. I'm getting a BLEU score. I'm getting the ROUGE scores, and then I'm returning the BLEU score and ROUGE 1. You can look at here the ROUGE 1. It means the ROUGE 1 means only 1 gram, so unigram. But you can look at ROUGE 2, ROUGE L, blah blah blah. Now I'm getting the evaluate BERT score. Now in the evaluate BERT score, you always remember this. BERT score is calculated using a BERT embeddings model, and then you calculate precision, recall, and F1 score based on it's a semantic similarity between the context, which is your top K documents coming from a vector database, and then you have the machine generated output, which is an LLM generated output. Now here I'm returning the mean of the precision, mean of the recall, and mean of the F1 score. And then I have a perplexity, okay, for evaluating it. Now that's where I'm using GPT-2. Now I will recommend that if you are going to focus on perplexity, you work with a better model like Llama 3, which is the really great capabilities in when you talk about open source models. Now I have a video on perplexity, guys. I created last year, to be honest, when more than a year ago, I will say, when nobody would have been talking about perplexity on the YouTube. Just after the rise of ChatGPT, I created a video on perplexity. So check that video out. I'll give that link in description. Now it takes a log likelihood. Okay, so I'm not gonna go deeper into it, but you can have a look at that. And then I have a diversity. On diversity, I'm looking at the unique n-grams. Okay, over there you can see it says unique bigram. Okay, looking at unique bigrams and then calculating the diversity scores, blah blah blah, and then returning it. And then I have a racial bias. I'm looking at hate speech and not hate speech. So it's a zero sort classification. Remember, so the machine generated output, if it says that, okay, the machine generated output has hate speech, then it will just return the labels. Okay, so you can see the bias score. And then, of course, you can get that using the logits or whatever you have there. And then I have a evaluate all function. Basically returns a JSON, or you can see it's BLU key value pair, rather, I will say, and it gives you that. This is what I have done. And then I have an app.py. So app.py is a Streamlit app where you can see a title. I'm loading that file, that class from that file, and I'm initializing the evaluator. And then I have a title and some pre-filled input fields that I have. I'll just do an alt Z just to show the demo. You can also directly send the data from your current system through a webhook, as I said, right? You can do that. Okay, for example, if you're using fast API or Flask, you can send the data from there to here. You can take it, and then you have some basic processing, guys. Just a button. When the button is clicked, the function will be called. That's it. I mean, this evaluator will be called. Now this is what I have done. I'll also show you the app here. This is the app that we tried it out. You can see the evaluation results. You can make it more beautified. You can beautify it, make it more beautiful, presentable. If you want to do that, please feel free to do. And this is where the library is. So let me show how you can create a Python library also. Let me show it to you guys. Okay, now it's very easy. For that, I have a folder called RAG Evaluator. Inside that folder, you put your files. You have to put your evaluator, test evaluator. In test evaluator, let me show you. So I have a test file. Now in the test file, I'm just writing a class called test rag evaluator. It has a function called test evaluate all. It basically helps you evaluate quickly, just as testing if the library is working or not. And then it has an evaluator, the same file. The file name is different, but this is the same file that you saw there in the VS Code, the same file. So this is your folder, and then it folder also has. Let me just show that you need an init.py file as well. So in init.py, I'm just calling it all. So all rag evaluator, and then let me just go back, and then I'll just go back, and then you need two more files. So you need requirements.py. So I'm not showing that the requirements, and then you need setup.py. So in the setup.py, if you look at here in setup.py, I have all the setups that one has to need, then one needs. Okay, you can see it over here. This is the setup where basically you're gonna push it. Now let me show how you can run this. I'll show the command. So first thing is, when your folder is ready for library, you have to do pip install wheel. So you have to install the wheel. Once you do pip install wheel, then you have to run this command called python setup.py sdist bdist underscore wheel. That's it. It will create the folder for you, a dist folder that you're gonna put it on PyPI, Python package manager. And then you need to install twine, pip install twine, and that basically helps you push the folder to PyPI. And then you can just have to use twine upload dist slash dot, because it's been in the same folder, and then it basically puts it on PyPI. Okay, so this is where it puts it. Okay, you can see it over here. I haven't updated the readme, I'll just do it, but you can see it's by AI anytime. Now you can use this library, feel free to use it over here. Let me just come here, in this rag evaluator, and this is where you can find out all the readmes and instructions. It explained everything over here. And yeah, this is how you do it, guys. It's not rocket science, to be honest. Okay, let me just make these changes. It's not be requirements spy. If you need that, I can also share you the backend code for at least when I created this. You can see this is how it looks like. These kind of things will be created. You can see rag evaluator, egg info, blah blah blah. Okay, you can find it out over here. This is how you build it. Now you have a Python library to work with, you have a Python library to play with, and you also have a Streamlit app for the evaluations. This is what I wanted to do in this video, guys. I hope you have developed a bit of understanding that what kind of matrices you have to work, the metrics you have to work, not matrices, guys, sorry for that, what kind of metrics you need to work with if you want to build an evaluation dashboard. I've shown you the RAG system evaluation dashboard, Streamlit tool, a Python library. All the codes are available. I'll also give the code for this dashboard. Probably I can also give the code how to pass the data from a current RAG system to this tool, like TrueLens does it. So basically you will run this on a different port, and fast API will be running on a different port where the RAG system is residing, right? So let me know if you have any question, thoughts, or feedbacks. All the code are available on my GitHub repository. I'll give the link in description. If you like the content, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel. That motivates me to create more such videos, guys. If you have any questions, you can also reach out to me through my social media channels. Find those information on channel banner and channel about us. We have a WhatsApp group. If you want to join, feel free to join. Find those link in again about us. That's all for this video, guys. Thank you so much for watching. See you in the next one.